Yeah, no, it's probably more than twice as big as the actual exam's going to be.
Okay, okay, good. For some reason, my brain was like, it's going to be twice as big as the review, and I was like, oh god.
No, no, sorry, the other way around.
Okay, gotcha, gotcha.
Hey, Matthew.
How are you doing?
Doing all right. How about you?
Doing good.
So I don't know how many more people are going to come, but if we want to go ahead and get started, well, let's go ahead and get started. So you guys have any questions from the homeworks that are due next week? Hi, Josh. 11
I
point.
don't have a,
Go ahead.
I don't have a question on this upcoming homework, but I have a question on, it was the last question on the previous homework. I think 22 on 11.1, 11.2.
Okay, let's do Josh's things first, and then we'll come back and we'll do that one.
Okay, sounds good.
All right, so on the 11.5 homework, question 1 here, find the area of the region bounded by the spiral r equals 4 theta for this weird looking loop thing here. Okay, so to find areas here in this polar coordinate, there's just a formula to it where that formula is the following, right? So it's the integral from wherever your angle stretches from, and then it's 1/2 r squared d theta. That was off memory. I think that's right. Okay, where the r is whatever the function value is in terms of theta. So we're just going to be plugging this 4 theta in for the r value into that formula. Also, we need to worry about the limits of the integral. And you kind of want to think of it like this was a unit circle. It's starting here along the positive x-axis, and then the angle is stretching up to pi over 2 all the way through pi. So this is going to be a function that's going from the angle 0 through the angle pi. So that's going to be the limits here for my integral. So we're going to do the integral from 0 to pi, and then 1/2, and then my r value was 4 theta squared d theta. Okay, so just squaring that off and cleaning that up a little bit. 4 squared is 16. 16 cut in half is 8. And we have that theta squared, d theta. Okay, and then so finally just do the antiderivative. So we're going to raise that theta up to a cubed and then divide. So the antiderivative 8/3 theta cubed. I should have drawn my integral symbol. And then that is going to be going from 0 to pi. All right, and you just plug pi into it. You don't have to worry about plugging 0 into it. So 8/3 pi cubed. I think that's all there's to it. Plug it in and see if we're right. 8/3 pi cubed. Yay. Okay, so does that make sense for that one? Just using the formula. This is the formula for finding the angle when you have your function in polar coordinates. The integral of 1/2 r squared d theta. You just plug in the r value that they give you for the boundary of your function. The hard part is figuring out which angle to put for your limits. So here from 0 to pi as if it was the unit circle. Oh, it also tells you. I didn't even see that. And then you just do the integral. Okay, cool. Okay, so then the other one was 11.2 and the last one, right? Number 12. Or 22, sorry, not number 12. Oh, yeah. Okay. Do you have like a specific question about it? Because this is a long one.
Yeah, it was just like the setup part. Like, the integrals are fine. It's just like, I don't know, the t's kind of threw me off.
Okay, so I did make a video like separately about just this one. It's in Moodle somewhere. I just did it last night, so it's okay if you haven't seen it yet. So are you okay with getting the dm value? Just like that. Does that look familiar for the dm value?
No.
No. Okay, cool. So the dm, that's like the differential of the mass of this shape. And this shape just ends up being like this wire that you get. So to find that dm, you have to do the square root. And that square root that we're doing is it's the formula that we've seen before when we were doing arc
length?
Yeah, the arc length formula stuff. So this just represents the tiny little bit of mass for these little sections of arc length that we're getting with this square root formula. So plug your parameters, x and y, into this, and it looks really gross to begin with, but it simplifies down just to be this, the square root of 2 e to the t. All right, so then once you have that, you have to do those 3 different integrals. You have your total mass integral, which is just the integral over that dm, so you're just integrating square root of 2 e to the t. But then you have 2 other integrals. The moment sub x, that's that integral over y wiggle. Where your x wiggle and your y wiggle, because we're just going like along the straight line, the x wiggle and y wiggle is just substituting in your parameterization. So y wiggle, you would substitute in e to the t sine t. Same thing for the moments of y. This would be the integral over x wiggle dm.
Okay, gotcha. It was just like figuring out how that stuff related to the parametric stuff.
Yes. So once you have this, you just plug that in, right? So every dm, plug in the root 2 e over t, and then the x wiggle and y wiggle, substitute in the parameters. And there is a separate video of this whole problem on Moodle, just because it's a really long problem, if you want to go through and look at it. You're welcome. Any other homework question stuff you guys want to look at? .5, number 4. Sure can. I think I'm missing a homework here. I think there's supposed to be an 11.7 up there. I'll have to check my stuff. All right, so 11.4, find the length of the spiral, r equals 2 theta squared, and it says they want your theta to go from 0 to square root 5. Whenever they give you the limits like this for the polar variable, you don't have to graph it, but if you're curious about what this looks like, we can graph it in Desmos. I think. Now that I say that, I'm not 100% sure. Desmos is going to like this. I think we just have to do r equals 2 theta squared. Oh yeah, that's working. And we want to go from 0 to square root of 5. So there you go. Just double check, make sure I got that right. R 2 theta squared, 0 square root of 5. So this is the thing that we're graphing. It's not the best. And we're trying to find the length of this spiral here. Okay, so to find the length of something in polar coordinates, again, there's just a formula to it. And that formula is, trying to do it by memory, the integral of square root. I have no idea. Is it dr d theta squared plus 1? All right, hold on. I gotta get my notes. I wasn't even close. All right, it's this. R squared plus dr d theta squared. And then d theta on the outside. Cool, yeah, so again, it's just a formula. I wouldn't expect you guys to have this formula memorized. When you do go to take the chapter 11 test, I think I sent out something that had the formulas for chapter 11. Does that sound familiar in your emails? Or is that a different class?
I just remember getting the final review stuff.
Okay, so maybe not. So I'll organize all the chapter 11 formulas and send that out, just so that everybody has the same sheet in front of them when they go to take the final, and all the formulas kind of organized. But this is the formula for arc length. So just going back, remember that the formula that we had for our question was 2 theta squared, where our theta is going from 0 to square root 5. All right, so plugging that in, our arc length is going to be the integral from 0 to square root 5 square root of, so the r squared, that's going to be that 2 theta squared all squared, plus the derivative of r squared. So the derivative of r, this is bringing down the 2, and it's going to be a 4 theta. And then still with a d theta all the way on the outside. Okay, cleaning this up. Still the integral from 0 to square root 5. Still have that awful looking square root, but now in the square root, 4 theta squared all squared, I'm sorry, 2 theta squared all squared is 4 theta to the 4th, plus this one squared, 16 theta squared, d theta. And this is not a good one, right? So that's kind of an awful looking integral, but hopefully we can simplify this down in such a way that we can actually do it. And I think what we should do here is we should factor the 2 terms that we have. So we still have the integral from 0 to square root 5, but inside the square root, I'm going to factor a 4 theta squared out of both of these terms. We'll be left with just theta squared plus 4 d theta. Okay, so now what I'm going to do is, because we have 2 separate terms that we're taking the square root of, I don't know why I put a t there. We have the 4 theta squared, and then we have this theta squared plus 4. We're just going to do the square root of each of these separately. And the square root of 4 theta squared is 2 theta. But then we still have that square root of the theta squared plus 4. Now we can do a u substitution. If we let u be that stuff on the inside of the square root, that theta squared plus 4, then du would just be 2 theta d theta. And that would substitute out with the 2 theta d theta that we already have in our integral. We're switching over to u's, which means I don't necessarily know what the limits are going to be, because I don't feel like switching it over that way. So let's just do it and we'll come back to it. So now we're just going to be doing the square root of u du for our integral. You can think of that as u to the 1/2. That's going to raise up to be u to the 3/2, and then we're going to divide by that 3/2, which is the same thing as multiplying by 2/3. Okay, so that's the antiderivative for my integral now, and now I can plug it back in terms of thetas. So in terms of thetas, it's going to be 2/3 theta squared plus 4 all to the 3/2. And then we're evaluating that between 0 and square root 5. Okay, so then we just plug square root of 5 into our antiderivative, minus plugging 0 into the antiderivative. If I plug square root of 5 into there, I still get the 2/3. That's going to be a 5 plus 4 is 9 to the 3/2. Okay, that minus plugging 0 in for my theta squared, which is going to give me the 2/3, and then that 4 to the 3/2. All right, I might need a calculator at this point. I'm going to try and do it in my head, but I'd probably get it wrong. Does that look right? 44. 38/3? Does somebody have a calculator in front of them? I do not have mine with me. Does that look right?
So many parentheses.
I know, sorry.
It's okay. Nailed it.
Okay, good. Let's solve for L. Well, let's look through the help me solve this. Let's see if 38/3 is right. And then I'll look through the help me solve this and see if I can see that stuff. So then when they tried to solve for L, let's try this. So we do that part. That's 4 theta. We did all that stuff. That came out to be that theta squared plus 4, I think. Yep. They don't do a U substitution, they do a V substitution. That's kind of weird, but yeah. It looks like they're going all through the same steps, they just label everything a little bit differently. But seeing it all like worked out like this, is that all right? Is there any questions about finding the arc length of this one? Yeah, I don't know why they label it with a V instead of a U. It's kind of weird. But it is just a U substitution that they're doing here. Yep, no problem. Oops. Cool. So that's 11.5. Is there any questions from the 11.3, 11.4? Okay, cool. I could have sworn there was an 11.7 somewhere. Oh, no, that was in my other class. Never mind. No, we're good. I'm not going to add any more homework for you guys. I was thinking of something else. But any other questions? Homework related? Chapter 11 related? past homeworks, future homeworks, prepping for the 11 test. We can talk a little bit about our future. So the Chapter 11 test is due May 4th. And I think what I'm going to do is have the final exam due for the 8th, which is that same week, but Friday. So that'll give you, 4 days to prep and take the exam whenever you have time in that last week. I'm also going to do the same thing as before with this Chapter 11 test, where I'm going to put up an assignment in Moodle that if you want to submit your scratch paper for the test, then you can do that, and I'll give partial credit for questions that you get close. So I definitely would recommend doing that. So last call, any other Chapter 11 stuff? For the final exam week, you mean? Or for next week with the Chapter 11 test? The exam week. Yes. We can definitely do that. I should be fairly free on that week, mostly. So we can do an extra one. I'll pick a time for it. Maybe we'll do it like on Tuesday, Wednesday, and Thursday for that week. That's a good idea, Josh. All right, so if you guys don't have any other homework questions, we don't have to stick around. I know that this Chapter 11 stuff, like, there's not a lot of homework for it, but I would recommend starting working on the final exam practice question stuff. It was a pretty big pamphlet that I gave you guys. I know most of it was worked out already, but still, if you have questions from that, just let me know. I'm going to try to come up with some other exam practice stuff too online here. So I'm going to make a practice final here in MyLabs, just because your exam is going to be in MyLabs, and I think it would be better to see the types of questions from there. It'll probably be a pretty big assignment, like 50 or so questions, but just know that your exam itself is not going to be that many. I'm kind of shooting for around 20 questions for the final exam. But all right, if there's no other questions, let's go. Let's head out. I'm gonna go eat some lunch. Thanks for coming, everybody. Thanks for bringing questions.
Bye.
Bye.
Thank you.
Yep. You're welcome.